In hydraulic analysis, you may encounter with three different pressures: atmospheric pressure, gauge pressure, and absolute pressure. What are they? So let's start with the atmospheric pressure. So we know pressure is force per unit area. Then atmospheric pressure is the weight of the column of air, that means the force divided by the unit area. So in this example, the atmospheric pressure felt by this person is the weight of the column of the air above this person's head divided by the area resting on that, right? So that's the atmospheric pressure, and that quantity is defined as 1 atmospheric pressure, and that is a standard value. So that 1 atmospheric pressure is also equivalent to 760 millimeter of mercury. So one of the unit we use to represent pressure is mmHg. So 760 millimeter of mercury or 10.33 meter of water. So we know mercury is denser than water, and that's why for the same pressure, uh, this will be 760 millimeter mercury, and uh, for the same at 1 atmospheric pressure, it will be 10.33 meter of water. The pressure can also be expressed in terms of millibar and kilopascals, and 1 atmospheric pressure is 1013 millibar or 101.3 kilopascal. But in civil engineering, pressure is mostly measured as gauge pressure, that is relative to atmosphere. That means we assume the atmospheric pressure is 0, and then everything we measure from there on. What are the absolute, gauge, and atmospheric pressures? So pressure in a complete total vacuum is the absolute pressure, okay? And that is usually referenced as P equals to 0. So when you start from absolute pressure, pressure at vacuum equals to 0, and then everything will be more than that absolute pressure. Now, the atmospheric pressure is the pressure at the sea level, and that is written as PATM. So that's the atmospheric pressure. So that is the weight of the uh, air column divided by the unit area is the atmospheric pressure. Now, in civil engineering, because we assume atmospheric pressure as 0, then the measurement of pressure more than atmospheric pressure is positive gauge pressure, and less than atmospheric pressure is negative gauge pressure. So gauge pressure is actually the measurement of the pressure relative to the atmospheric pressure. Okay, so when the measured pressure is atmospheric pressure, then we assume that is 0 pressure because we are measuring from the atmosphere. So atmospheric pressure is assumed to be 0. Now, if the pressure is more than that, we get the positive gauge pressure, and if the uh, pressure is less than atmospheric pressure, then we get the negative gauge pressure. So absolute pressure is always positive. So because we measure the absolute pressure from 0, so absolute pressure, if this is the point, if this is the point of the pressure, then from this point to upward, absolute pressure is positive. But because this is less than atmospheric pressure, and if you measure the gauge pressure, then this will be negative gauge pressure. Similarly, if the pressure is at this point, that means more than atmospheric pressure, then that will be positive gauge pressure, and absolute gauge pressure is from here to this point. So that is gauge pressure plus the atmospheric pressure gives us the absolute pressure. And this atmospheric pressure is also called this barometric pressure. And we know the barometric pressure We can measure in terms of mercury, in terms of water, in terms of Pascal, millibar, and so on. Atmospheric pressure is not constant. It changes with the height, so it changes with the location at the sea level or at the Mount Everest or above that, it is different. And also it depends on the temperature. So this figure here shows the relationship of temperature, altitude, and the atmospheric pressure. So you can see at the sea level at around 15 degree, we have this 101.3 kilopascal of atmospheric pressure. But if you go to the top of a troposphere, which is 11 kilometer above the surface, then we get this 22.6 kilopascal, and then top of the stratosphere, we get only 5.5 kilopascal, and then we get even smaller pressure, so it goes to 0.9, and then uh, it when it is around 47.3 kilometer, we get the pressure of 0.1 kilopascal only. However, for the civil engineering purpose, for design of any hydraulic structures, we don't need to be that concerned. We can assume the atmospheric pressure is zero. So we don't need to change the uh, effect of atmospheric. Obviously, depending on the height and depending on the temperature, if you are at sea level or if you are designing the structure at 4,000 meter, there will be some difference, but not very much difference that would impact the design itself. So basically, for civil engineering purpose, we just assume the one constant atmospheric pressure, and generally we use that as a gauge pressure. So atmospheric pressure is zero wherever we design our structures.